going to discuss about the spontaneity of effector. So initially I told you that second law deals with the spontaneity of a process. So what is spontaneity? Spontaneity, it is nothing but when a system has its own urge to happen. Okay? The system which will do the thing by itself, they are called spontaneity of a process. So spontaneity can be of two types, where initiation is not request, nobody has to request them. And second, where initiation is required. So there are various processes where initiation is not required, both in chemical and physical processes. And there are some cases where you find once you initiate it, then after that the system moves by itself. It is found most of the processes, when they occur spontaneously, there is release of energy. Release of energy takes place. And release of energy in the form of heat. Because they move from higher potential energy to the lower potential energy. And in this process, the energy is released. So you can say that all exothermic processes are spontaneous. But if you say in the reverse way, that all spontaneous processes are exothermic, then will be wrong. So reverse is not true. We can say that exothermic processes are spontaneous, but all processes are not spontaneous. All spontaneous processes are not exothermic. Because most of the thing which happens in front of us, right from our childhood, we have seen, which occurs spontaneously in the nature, many of them are endothermic in nature, like melting of ice. We know it very well that if you have to convert solid into liquid, you have to supply heat. In case of ice, we don't heat it, but ice cubes or ice crystals absorb the heat from the surroundings. Then the evaporation of water. At home, we boil water. When you boil water, we supply heat, then the liquid goes to the vapor state. In normal processes, what happens? In the nature, water evaporates. But it is the same phenomenon. In the evaporation also, the liquid water or any liquid absorbs it from the surrounding and goes to the atmosphere. So this is also spontaneous process, but this is endothermic. So as I told you, we should not make a sweeping comment that the processes are spontaneous because they release heat. They move from higher potential energy to the lower potential energy. No. So when we started searching the reasons for the spontaneity, then we have come across two factors. One is that when a system moves from one phase to another by itself, it does it so to acquire more freedom, freedom of movement, freedom of randomness. From that, we got the concept of entropy. Okay, and we have also found that entropy of the universe is always increasing. Because of that, everything around us in the universe, they happen by itself. Hardly we do anything for the universe. Whatever we do for ourselves only. And this also being added to the total energy of the universe. Then we have studied entropy under different conditions. We have studied entropy in a reversible process. We have studied entropy in a irreversible process. Then we studied entropy in isothermal process. Then we studied entropy in adiabatic processes. Everything we have discussed. Okay. And we have found how whatever the amount of the energy is being spent in acquiring the maximum degree of freedom or randomness, we cannot calculate. But we can calculate or find how much amount the entropy content in the system at the beginning, at the end. And we can subtract one from other to find out the change. So what we can say, the entropy is a state property. So it is a state properties. Because of that, we can find out the change by subtracting the initial entropy from the final entropy. And in case of a chemical reactions, we can find out the entropy change by subtracting the sum of the entropy of the reactants from the sum of the entropy of the products. Entropy it is an extensive property. If the amount of the substance is less, entropy is less. If the amount of substance is more, entropy is more. So the evaporation of water, if you compare the evaporation of water in a small pond, a big lake, a river or sea, you will find obviously the entropy will be the highest for the sea because the volume of the water is more. More and more amount of water is being converted into vapor. So in that case, the water vapor will be more above the sea. Okay, now we'll come to the another factor, that is we call it free energy. Okay. Okay, then let me write down. We call it free energy or we call it Gibbs free energy. Right. No, first Gibbs free energy. It is the thermodynamic quantity of a system that decrease in whose value during a process is equal to useful work done by the system. Or you can write, it is the useful work done by a system. It is denoted by mathematically he gives free energy can be expressed as G is equal to H minus Ts. Where H is the enthalpy of the enthalpy. S is the entropy of the system at temperature T in Kelvin. gives free energy change delta G. Gives free energy is a state function. Therefore, the change in Gibbs energy Gibbs energy depends only upon the initial and final states of the system. And do not depend upon the path by which the change has been achieved. Gives free energy change is represented by delta G.
Sir, done.
Okay. All right. So we'll write down now. I'll write down directly the derivation. I will not do for you unless I will have problem. Right. At take at constant temperature and pressure. Gives energy change is expressed as delta G into delta H T into delta S. In all spontaneous process, be it physical or chemical, gives energy change is lowered or negative. Should be negative. If it is positive, then if it is positive, the processes are not spontaneous. If it is positive, then the processes are not spontaneous.
Sir, done.
Done.
Okay, so now we'll see. See, now our purpose is to what? we have to see that under what condition delta G can be negative. Okay? Conditions under which the processes can be spontaneous. Means what? Or delta G can be negative. So what is our expression? Expression is delta G is equal to delta H T into delta S. Okay, now see. Any processes can be of two types. It can be exothermic or endothermic. Any process can be either exothermic or endothermic. In exothermic processes, delta H is negative. And in endothermic, try to understand, then you will write. Processes, delta H is positive. Okay. Now we will go for exothermic process. A. Exothermic process. Okay. क्या होगा इधर? Delta H is negative. And these are the probability. Huh? And if delta S is positive. See here. In this case, what will happen? Delta G, delta H, this. So I'll write now here. Delta H. Because you have already taken the condition is this. We'll write now. Taking the conditions under consideration. একটু জল লাগবো নাকি? লাগবো লাগবে। See here. Delta H. And this. So ultimately it will be what? This is negative, this is negative. So what will now? What will get? Is it not going to be a large negative value? Huh? That is what you can write. That is a large negative. I will not write here. Equal to what? A large negative value. Therefore, what I can say, this THE, this processes are highly spontaneous. These processes are highly spontaneous.
So then,
Okay, now we'll go to second condition. What is the second condition? If it is negative. Okay. Then what will happen now? This. So it will be what? Delta H. See, negative and negative makes it positive. This. Now see. This can be possible only when if the product of T delta S is less than delta H. Because this is positive. If this value is less than this, then only it can be negative. In this processes, delta G can be negative if the product of T into delta S is less than delta H. Okay, that is only possible. So we know that entropy is directly proportional to temperature. If you supply more heat, the more system will undergo randomness. Because of that, you find the ice becomes water, liquid water, and liquid water becomes water vapor. Okay? That is only possible if the magnitude of T is less, or the system is carried out at low temperature. So what we can conclude now? Hence, it is spontaneous only at low temperature. So you can do it by your own logic. I need not tell you.
Sir, done.
Done.
Yes, sir.
Okay. Now we'll go for endothermic process. B. Endothermic process. Endothermic process means you have to heat. Okay. So, condition one. Delta H is positive. Endothermic process, delta H is always positive. And if delta S is positive. So what is going to happen now? In this case, what will happen? Putting these conditions in the equation, then delta G equal to delta H minus T into delta S. What you will get now here? Delta G is positive. Okay, I'll write here. Delta H as delta H and T into delta S. See, this can be negative only when this magnitude is more. Under this condition, delta G can be negative only when the product of T into delta S is more than delta H. That is possible only when only at higher temperature. Okay. So in that case only you will find that delta G is equal to plus delta H T into delta S is equal to negative. So such processes are always carried out at higher temperature. Such processes are always carried out at higher temperature. ওখান তোমার দরকার নাই না
Sir, done.
Okay. Now we'll go for the second condition. Second condition is this. Okay. So what will happen now? So it will be plus delta H plus T into delta S is equal to what? Positive. All right. So in that case, what will happen? Delta G will be negative. In now in this condition, delta G is always positive, and hence such processes are not spontaneous. So this type of thing will never occur, and will never occur.
Sir, done.
Okay, very good. Okay, I'll write a summary, okay? we'll write a summary here. Okay. Yeah, you write energy factor. Energy factor means what? Enthalpy. Entropy factor. Okay. Sign of delta G. Hey, here I'm going to write, I'll tell you what I'm reading. Spontaneity. Of the process. Don't say sorry, we cannot see. Spontaneity of the process. Okay. So what is this? Energy factor is what? Delta H. What is this? Delta H. 1. We'll write here. Positive. This is positive. So this will be what? Negative. That I'm writing the summary. You know what is this? Delta G is equal to delta H into T into delta S. So what will write? Spontaneous at all temperatures. Don't forget. Second. So no, don't write. Here you write negative. Please write negative. Then second, negative. Here we'll write negative. Okay. Then here I'm going to write A, negative. When it will be negative? When delta H is more than T into delta S. So what will write now? Spontaneous at low temperature V positive when delta H is less than T into delta S. So when it can be more? When T is more. So what will write? Non-spontaneous at higher temperature. Achha. Then third, positive. And this is positive. Here again I'll write A, negative. When it will be negative? When T into delta S is more than delta H. So what should I write? Spontaneous at higher temperature. B positive when T into delta S is less than delta H. So what will write now? Non-spontaneous at lower temperature. Then condition 4, positive, and this is negative. We'll write non-spontaneous at all temperatures. Non-spontaneous at all temperatures. See, this is a summary. Try to remember, it's very easy.
আজকে তোর মনে পড়বে তো এই জারটাকে মাঝে দেবে তো আমি এখন জল আমিও ভুলে যাই কবে থেকে আমি মনে করছি এটা তো মাঝে
I'm on.
কিছু দিয়ে হবে না নর্মাল মাছ দিয়ে হবে
সপ্তাহের মধ্যে মাতিও না।
কিচ্ছু লাগবে না এমনি দিয়ে সাবান দিয়ে যেরকম আমরা বাসন মাঝে সেরকম মাছ দিয়ে কিছুই না কোনো স্টেইন নেই ধুলা আমার মাছতে ইচ্ছা করে তুমি সব বাসন দিয়ে মাছ
Udah.
Standard free energy change. What is that? Delta G0. Want to put standard? This. What does it mean? As I told you, these are being done at standard state. If we carry out chemical reactions, we take 1 mole of a substance at a temperature of 298 Kelvin and at 1 bar pressure. the standard free, sorry, I like that. Here you please write gives. Standard gives free energy change is defined as the free energy change in which the reactants in their standard states. Okay, it is 1 mole under 1 bar pressure at 298 Kelvin are converted to products in their standard states. It is denoted by delta G 0. So mathematical wise, what we can write? Mathematically, delta G 0 is equal to, sorry, sum of the standard gives free energy of formation of products. Okay, I remember bracket minus sum of the standard gives free energy of formation of reactor. है बहुत लंबा. Okay. So ultimately what I will write now here? Delta G0 delta G products minus delta G0 reactant. So if any sum is given, add it and subtract. I told you some sums are very easy, but only thing is that The sums are little longer.
এখানে আমাদের পেঁয়াজ আদা লঙ্কা দিয়ে মাখা মাখা একটা খাওয়া যাবে না।
Here, when you do the sums, you have to remember one thing. Note. See, we did not make any elements. Elements are already there in the nature. Okay? So we write here. The standard gives energy of formation of elements in their standard states. Don't get scared. These are the conditions. Is assumed to be 0. That is, see here, delta G 0 for hydrogen. We'll have to consider G. Okay? Delta G 0. For example, oxygen is 0. Similarly, for nitrogen, it is 0. Same is the case for fluorine. Huh? Chlorine, bromine, iodine. Please remember. Huh? Delta G 0 for graphite, carbon is 0, etc. This for your numerical. To standard gives, okay, we'll write here now. Relation between standard gives free energy change and equilibrium. constant. See, here I'll write the expression only, because when I go to the equilibrium, then only you will understand. So please don't mind. I'll simply write there this. Delta G0 is equal to minus R T ln KC. अभी याद रखो, बाद में हम सब समझाएगा. Okay. Now ln is exponential base logarithm, or what I can write, I can convert into natural logarithm 10 base. If you multiply 2.303, then you get this one. It comes to 2.303 RT log KC. So here I'll write it is KC. And this is delta G 0. And second one is relation between standard gives free energy delta G0 and electrical work done in an electrochemical cell. That also I'll discuss later on when I go to redox reaction. We call it or EMF, electromotive force. E0 cell is equal to delta G0 minus NF E0 cell. Okay, so I'll write where N is equal to number of moles of electron. F is equal to electrical charge carried by one mole of electron. Okay, is equal to what? 96,500 coulomb. And what is E0 cell? E0 cell is equal to electromotive force. Bas. With this, I finish your. Oh, no. I have to write the third law of thermodynamics.
এই কথা সবগুলো কোথায় এবার বেশি
Water
শিলংয়ে তো আরো কম
So done.
Now we'll go for third law of thermodynamics. Third law of thermodynamics. At absolute zero means what? At this is the okay, huh? At 0 Kelvin. Okay, I'll not write like this. You are dangerous. At 0 Kelvin. There is no disorder of a perfectly crystalline substance. That is a perfectly crystalline substance has zero entropy. This is the third law of thermodynamics. Actually, there are 4 laws are there. I told you. Note. This is for your entrance. There are some certain substances which possess certain entropy even at 0 Kelvin or absolute zero. It is called residual entropy. This is only for your entrance exam. Residual entropy. Okay, I'll take 2 minutes to finish it, then I'll just talk to you for 2 minutes.
Sir, done.
Okay, now see. Though you call it third law, but thermodynamics consists of 4 laws. What is first one is called is the zeroth law. In zeroth law, what do you find? We talk about the thermal equilibrium. If two substances are independently in thermal equilibrium with a third body, then these two substances also are in thermal equilibrium. That is, they have the same temperature. Then in first law, what you do? First law, we try to find out relationship between heat and the work. Relationship between work and the heat. Okay. In second law, what we discuss? In second law, we discuss about the spontaneity of a process. Okay, there we come across entropy and the free energy, and we find ultimately this is the culmination. We find that all exothermic processes are spontaneous. Okay, but all spontaneous processes may not be exothermic. And then we come across 2 factors. One is called the entropy or disorderness, and second one we find free energy. And ultimately, when you combine both of them, the enthalpy and the entropy together, then we get another factor, we call it free energy. And we find ultimately the culmination is that, or conclusion is that, all spontaneous processes have negative free energy. And in the third law, we find if any substance is having a perfect crystal, means there is no defect in it, then at absolute Kelvin or 0 Kelvin, we find they do not have any randomness or disorder. That is, they cannot move. So they have 0 entropy. But if some substances still then they show some entropy, we call them as residual entropy. Actually, now, from your first book, out of the 7 chapters, we have finished 6 units in exhaustive way. Now, 7th chapter is equilibria. And after that, your second book starts. Your second book deals with the redox reaction. Then it deals with the hydrogen. Then it deals with the water and hydrogen peroxide. And after that, you have S block elements, P block elements, group 13 and group 14. And after that, you have organic. Organic 2 chapters are there. So equilibrium I will not do now. Equilibrium, if necessary, I will do next year. Because this is very important for your entrance exam. So I will do it next year. And now what we are supposed to do? Should I start with organic or should I start with redox reaction? I would prefer to start with redox reaction because it is a very small chapter, and this year many things from that chapter is being removed. So next Wednesday, I'll start redox reactions. I told you the thermodynamical equations, calculations you do at home.